Okay, in this video we are going to review exponentials and logs for the AP Calculus exam, either the AB exam or the BC exam. I'm going to kind of assume that you're already done with the course and you're just getting ready for the exam, or at the very least you're done with logs and exponentials in class and you're getting ready for a test or a quiz on that topic. So what I'm going to do is start with a quick overview of exponentials and then natural logs, and then I'm going to do problems that involve derivatives, some with integrals, and then some with the limit definition of the derivative. And I think it might run a little bit long, so in the description I'll put timestamps so when I get to each of those things. So let's get started with this. So first, let's talk about some properties of e to the x that I think you should definitely have memorized, know all these things front and back. So first one is the graph, which features this point, 0, 1. And of the graph, I think there are a bunch of things you should be aware for the function. So first, the domain is all reals. And the range is y is greater than 0. The y is greater than 0 part is going to really help you out when you have to make number lines for sign charts and things like that to test first derivatives and second derivatives. So definitely make sure you know all that. There are two limits you should know for sure. So the limit as x approaches infinity of e to the x is infinity, and it gets there really fast. So it dominates polynomials and things like that. And the other limit is that the limit as x approaches negative infinity of e to the x is 0. That comes up a lot, especially with limits or horizontal asymptotes of like non-rational functions. So make sure you are aware of those limits. And then, of course, you need the derivative and the antiderivative. So the derivative of e to the x, very famously, is e to the x itself. And then the antiderivative is also e to the x, but don't forget plus c. So you're never going to forget plus c on the calculus exam. So that's e to the x, and that's by far the most common exponential that you'll run into. But you might also see just a to the x. So in the event that you see that, pretty much everything is the same, but there are two things that you should be aware of. The derivative of a to the x is equal to a to the x times the natural log of a. So don't forget that. So you got to remember to multiply by the natural log of a in that case. And then the antiderivative is kind of similar. There should be a 1 over the natural log of a, and then a to the x, and then plus c. So it's those the natural log of a parts there. There's also one really common property that I think you should know, and it's e to the x plus y is equal to e to the x times e to the y. The reason you should really be familiar with that is that it comes up frequently on separable differential equations. So that'll be like one side, you'll have dy dx is equal to e to the x plus y. And you have to remember you can use this property, and then you can bring e to the y over and all that. So I would say exponentials show up a ton on separable differential equations. So it's one of the places you're definitely going to see them. All right, let's talk now about natural log. So some of the things I think you should know about natural log are, first of all, its graph. Its graph has an intercept at 1, 0, and that's kind of like the only super important point to know. There are some values you should know, though, for sure. So the natural log of 1 is 0, as you can see from that point. And the natural log of e is 1, so that comes up a lot as well. So those are some values I think you should know. The domain and range are really important. So the domain is x is greater than 0, so you have a vertical asymptote at x equals 0. And also, I mean, if you think about the graph, and I do this all the time when I'm testing derivatives and things like that, natural log is negative between 0 and 1, and then positive after 1. So that's really useful. And it has a range of all reals. So you need to know the derivative for sure. So the derivative of natural log of x is 1 over x, but then you should include x is greater than 0 because natural log has a domain of greater than 0, and 1 over x, without that exclusion, it looks like you could plug in a negative, which you definitely can't. You should also be aware of, so not the antiderivative of natural log necessarily, I'll get to that in a second, but definitely the antiderivative of 1 over x is going to come up. And that's the natural log of the absolute value of x, and then don't forget your plus c. So make sure you know those two things, and never forget those absolute values. They're pretty important. If you're taking BC, you should also know the antiderivative of natural log. So if you're just taking AB, you don't need to know this, but if you're taking BC, the antiderivative of natural log of x is x ln of x minus x, and then plus c. And when you do that, if you had to actually calculate it like you forgot, you'd be using integration by parts. So if you're in AB, you don't know what I'm talking about, and that's totally fine. There are three rules that I think you should know for natural logs because they come up in kind of different circumstances. So the rules are, if you have a times natural log of x, you can make that natural log of x to the a. So use that property in both directions on the exam from time to time. In particular, when you're solving differential equations, sometimes you take the coefficient and bring it up as an exponent. So that's the first property. The second property is that the natural log of a plus the natural log of b is equal to the natural log of a times b. So that's one that you can use before you take a derivative. If you have a natural log of like 5x, you can make it the natural log of 5 plus the natural log of x and then like go for it. The third rule actually gets used a lot. So it's a natural log of a minus the natural log of b is equal to the natural log of a over b. So you're going to end up using this all the time when you take limits. So if you have the limit of a natural log minus a natural log, as you go to infinity, you're going to get infinity minus infinity, and the way you deal with that is bring it all into the same natural log, and then you can deal with it. It's usually like in a L'Hopital's type situation inside the natural log. So make sure you're aware of that. That happens on free response questions. In particular on the BC exam, I see that a lot. But L'Hopital's is now on the AB exam, so you might also see it there. All right, now what I'm going to do is a bunch of problems that look like they involve derivatives and exponentials and logs. Mostly exponentials, but let's do this. So if you want to screenshot these right now and give them a go on your own, you could do that. I'm just going to kind of maybe fly through them, maybe not. So number one, that's pretty standard, right? It's chain rule. So it's going to be e to the 2x and then times the derivative of 2x. So it's going to give me 2e to the 2x. All right, number two is a little more complicated, right? Because it's not e to the x, it's 5 to the 3x. So 5 to the 3x, the derivative of that is going to be 5 to the 3x times the natural log of 5. And then I need to chain rule that 3x, so it's going to be times 3. All right, not so bad. The next one, it looks like a product of two functions, so I'm going to use a product rule on it. So it's first times derivative of the second, which is 1, plus second, which is x plus 3, times derivative of the first, and just don't forget the chain rule. So that's going to be 2e to the 2x. And then I'm just going to kind of factor this. So I'm going to take e to the 2x out and get e to the 2x times the quantity 2x plus 7. All right, let's take a look at the next one. We want to find the tangent line to f of x equals e to the 2x at x equals 1/2 natural log of 3. Okay, so let's see what we got. So first I'm going to find f of 1/2 natural log of 3, which is going to be e to the 2 times 1/2 is just 1, so it's going to be e to the natural log of 3. And e to the x and natural log of x are inverses of each other, so e to the natural log of 3 is actually just 3. That's another property that I probably should have included because it does come up, especially when you're solving differential equations, which is kind of like where everything comes up. Now we need to find the slope, so I'm going to find f prime. Just remember the chain rule, so that's 2e to the 2x, and then I'm going to substitute in, so I get this, and just like before, it's going to end up 2 times 3, so 6. And then our equation, well, it's going to look pretty ugly because that x-coordinate isn't super nice. So we get that. And you're going to leave that in point slope form unless something makes you get it out of point slope form. Point slope is the way to go. All right, we have x of t, a position function, and we want to find v of t. So this looks like a product, so I'm going to use product rule and try not to forget the chain rule. So v of t is first, or I should say v of t is x prime of t. So if this is a free response, you definitely want to write that down. Make sure you're drawing the connection between what you were given and what you're finding. So it's going to be first, derivative of the second is negative sine of t, plus second, which is cosine of t. Derivative of the first is going to end up negative 8e to the negative 2t. And then I'm just going to factor this. So I'm going to take out negative 4e to the negative 2t from both. I get this, and that's going to leave me with sine of t plus cosine of t. All right, so that's my velocity, and maybe I would have to substitute something in, like maybe a pi over 2, something like that. Who knows? Let's take a look at the next one. The limit as x approaches infinity of the natural log of e to the 4x minus x all over 2x. So one line of thinking on this might be that natural log of e to the 4x minus x, if x goes to infinity, is basically you can disregard that x. So natural log of e to the 4x. Natural log of e to the 4x, because they're inverses, or you could just use the exponents become coefficients, just 4x. And then you just have 4x over 2x and you get 2, which is actually going to be the answer, but I'm going to L'Hopital's my way through this. So this looks like infinity over infinity to me. When you get to the point where you're taking the exam, you want to have a lot of options of ways you might approach things. So that's my first thought on this. And I'm going to use L'Hopital's, so it's the derivative over itself, and then all over, so that's the derivative of the top, right? And then we're going to divide by the derivative of the bottom. So derivative of natural log is 1 over u times du, I guess, and then divided by 2. So here I'm going to pull out 1/2 and actually use L'Hopital's again, because this thing is still indeterminate. This is like an annoying choice for a problem. So derivative of the top is 16 e to the 4x, derivative of the bottom is 4 e to the 4x minus 1. I'm going to just take the limit at that point and get 16 over 4, which is 4 times 1/2, which gives me 2. All right, let's do one more derivative problem, then we'll move on to integral type problems. So this is implicit, and we want to find dy dx at the point 1, 2. Okay, so let's do this. Here we go. So it's the derivative of e to the xy is e to the xy times the derivative of xy. The derivative of xy is first derivative of second plus second derivative of first. So remember, when you're doing implicit, the derivative of y is dy dx. And then we need the derivative of y cubed, so that's going to be 3y squared, but chain rule gives us dy dx. The biggest mistake I see people make with implicit is they forget the derivative of a constant is 0. So this whole thing is just going to be equal to 0 because the right side is a constant. What I'm going to do here, because I have to find dy dx at a point, I'm going to substitute x equals 1 and y equals 2 right away. So I end up with e squared dy dx plus 2, and then plus 12 dy dx equals 0. Now I'm just going to go through and solve for dy dx. So this is all arithmetic, basically. I guess it's kind of algebra. It's algebra and arithmetic, but not really calculus at that point. Okay, next thing we're going to do, some integral problems. So if you want to screenshot this, give these a try, and then I'm just going to solve them. So let's do it. First one, I'm just going to reverse the chain rule, or do kind of a u substitution, right? There should have been a 4, so I need a 1/4. 10 over 4 is 5/2, so I get 5/2, e to the 4x, and then plus c, so we're never forgetting plus c. The next problem is really similar. I'm going to reverse the chain rule or use u substitution on the first part, get 1/2 e to the 2x. Then just remember 3e is a constant, so the antiderivative of that is just going to be 3ex. So I get plus 3ex and then plus c, and we're done. The next one, this kind of thing comes up a bunch. They'll give you a derivative that doesn't actually have an antiderivative that we can calculate, but they'll ask you what f of x could be. They just want you to write down an accumulation function. So my function here, I'm going to say f of x is the value that I know, which is 4, plus the integral from the x-coordinate where I know that value, so 1 up to x, of, I'm going to use a dummy variable, so e to the t cubed, and then dt. And I can't get a better answer than that, so I'm pretty much done there. Next problem, average value. So average value is the integral divided by the interval. So what I mean by that is it's the integral from 3 to 6 divided by the interval from 3 to 6, which is going to take 6 minus 3. And now we just value it. I'm going to take out 1/3. The antiderivative of 1 over x is the natural log of the absolute value of x. And we're going from 3 to 6. So this is going to be 1/3 quantity. I'm dropping the absolute value here because 3 and 6 are both positive. And then I'm going to use that rule, right? I have natural log of something minus something becomes the natural log of the first divided by the second. And so 1/3 natural log of 2. All right. Number 5 looks to me like a separable differential equation, which is where these come up frequently. So I'm going to separate dy over y is 4x over 1 plus x to the 4th dx. I'm going to integrate both sides. On the left side, I get natural log absolute value of y. I put the plus c on the side with the independent variable, so I didn't write plus c yet. On this side, it might look like a natural log, but it actually doesn't work out because if you did u substitution, where u is 1 plus x to the fourth, you would have 4x cubed. We don't want that. Well, we don't have that. It's not that we don't want it. So once that doesn't work, I start thinking, is this thing arctan? And it does look like an arctan. It looks like if I make u equal x squared, I can get an arctan out of this. So what you'll get when you try it on your own is 2 arctan of x squared, and then plus c. We need to solve for c. So up here, I'm going to exponentiate before I solve for c. If you have to exponentiate, so if a natural log shows up when you're doing this kind of process, you should exponentiate first, then solve for c. It's just much easier. So let's use this ordered pair. The arctan of 0 is 0, so we actually end up with c equals 3. And so our solution is 3e to the 2 arctan of x squared. So that's one you might want to try again. The next one looks kind of similar, but simpler. So I'm actually just going to find an antiderivative, like this. I have plus c. I'm going to solve for c using what I know. So I know this point. So negative 45. So remember, e to the 0 is 1. So negative 45 plus c is equal to 4. So c is 49, which means I know the actual function is negative 45 e to the negative 2 over 3 plus 49. And now I can solve for y of 3. So y of 3, just plug it in. Negative 45 e to the negative first plus 49. All right, and then number 7, certainly not the hardest of these problems. I look at it and I think, if I were in Calc BC, I might think, oh my gosh, do I have to do integration by parts? But this is actually just a u substitution. You should always start with hoping that that works. So make u equal e to the 4x squared is one approach, or make u equal 4x squared. Either way you do it, there should have been an 8 on the inside there, and there wasn't, so we're going to get an 8 on the inside, a 1/8 on the outside to balance it out, and then e to the 4x squared, and then don't forget plus c. All right, so the next thing I'm going to do is a couple problems that look like the limit definition of the derivative, because this comes up on multiple choice a lot, so make sure you're not afraid of these. So here are examples. So yeah, when you see something like this, the limit by itself, you might actually think I should use L'Hopital's rule, which will work. You just have to be careful of what the variable is. So if you're taking the limit as h approaches 0, your variable is h. If it's a limit as x approaches something, your variable is x. So just be aware of that if you do want to use L'Hopital's. I don't want to use L'Hopital's because I'm very familiar with the limit definition, so that's what I'm going to go with. So this first one, limit as h approaches 0, that immediately in my mind says limit definition. So I need to figure out the function. It looks like the function is actually just the natural log of x. And then since it's the limit definition is f of x plus h minus f of x over h, limit as h approaches 0. So f of x plus h, that means that the x I'm using must be 3e squared. And then I know the derivative of natural log is 1 over x, so this is just going to be 1 over 3e squared. The next one, it's even more explicit. It's the alternative derivative definition, where you get a value instead of a function, kind of. So I know I'm finding f prime of 5. So that's actually just going to be 1 over 5. And that's the answer to this question. So the next one, it looks to me like the function is e to the x. And I'm trying to find f prime of negative 3. So the derivative of e to the x is e to the x, so this one's just going to be e to the negative 3. And pretty much all of these limits look very challenging if you don't recognize what they are. If you do recognize it, they're not bad at all. So let's do this last one. Looks to me like it's really similar to number 2. It's like the alternate definition of the derivative. And that would mean that f of x is the natural log of 2x minus 3. And I'm trying to find the derivative at 4, because its limit as x approaches 4. So you would want to confirm that, like, when you plug in 4 to your function, you get the thing in the top right of that fraction there. So if I plug in 4, I get natural log of 8 minus 3 is natural log of 5. So it fits the form. So here the derivative, f prime of x, is going to be 2 over 2x minus 3. And so I'm being asked to find f prime of 4, so plug 4 in, and I just get 2 over 5. All right, so that's like a really quick review of pretty much everything I think you need to know for logs and exponentials on the AP exam. There's one other thing that I think you should definitely do if you still have time, and that's go out and find a bunch of separable differential equations and practice with those, because logs and exponentials come up quite a bit when you're dealing with those. All right, that's the entire thing. Good luck on the exam. I hope you found this helpful, and thanks for watching.